Now, starting with our first unit, semiconductor diode, first topic that is type of material. Materials can be classified into three categories based on the electrical conductivity, such as conductor, semiconductor, and insulator. Conductor are the materials which allow electricity to flow through them. The outermost electron in the atoms are loosely bound in conductor, and at room temperature, this electron can easily move in the space between the atoms. This movement of the electron is the fundamental term which decides its electrical conductivity. Whereas semiconductors are the material whose electric conductivity is less than conductor and it is more than insulator. So we can say that semiconductor can work as a conductor as well as the insulator. The concentration level of free electrons in semiconductor lies between the density of the electron in conductor and insulator. It can be a compound such as gallium arsenide, or we can say we are having a pure element such as germanium and silicon. Whereas insulators are the material that hinder the flow of electrons from one particle to another. Hence, here in insulator we are having no conductivity. The electrons in the outermost shell are tightly bound. So at the room temperature, they doesn't get sufficient heat to discharge from the outermost shell. Thus, electron cannot move freely and hence we can say that we are not having any conductivity in insulator. Now, all these three types of material can be differentiated with the help of energy band gap theory. The energy band gap theory mainly explains the mechanism of the movement of the free electron from valence band to the conduction band. In the diagram, you can see that starting with the insulator, the energy band gap between your valence band and the conduction band is very large. Whereas in semiconductor, the band gap between your valence band and conduction band is small. And in conductor, you can see that the two bands are overlapping with each other. As in conductor, the bands are overlapping with each other, the electrons can easily move from valence band to conduction band. Whereas in semiconductor, if we provide some external energy to the electrons present in the outermost shell of your valence band, the electrons can easily move from a valence band to conduction band. Whereas in insulator, as the band gap is very large, the electrons cannot move from valence band to conduction band. So based on this energy band gap theory, you can see that the difference between the three materials, that is insulator, semiconductor and conductor. Now, doing the comparison part of all the three materials based on the different parameters, the first one, that is the definition, we can say that conductor are the material which allows the flow of charge, whereas semiconductor are the material whose conductivity lies between your conductor and insulator are the material that does not allow the flow of current. Based on temperature dependence, we can say that the resistance increases with temperature in conductor, whereas in other two, the resistance decreases with increase in temperature. If we talk about the conductivity, we'll be having very high conductivity in our conductor. The conductivity, we are having an intermediate conductivity in semiconductor, and in insulator, we can say that we are having no or very low conductivity in insulator. If we talk in terms of conduction, so the conduction is due to free electrons in metal bonding in conductor, whereas in semiconductor, the conduction is due to the movement of electron as well as holes, whereas in insulator, there is no free electron and holes, and hence there is no conduction. Then based on band gap, we can say that there is no or very low energy gap between your conduction and valence band in conductor. Whereas in semiconductor, the band gap is of very small value, that is of 1 electrovolt, and in insulator, the band gap is very high, that is of more than plus 5 electrovolt. The resistivity is low in conductor, normal in semiconductor, and very high in insulator. The coefficient of resistivity is positive in conductor, and whereas in other two it is negative. We can see the examples of conductor are copper, silver, aluminum. Examples of semiconductor are silicon, germanium, and insulator that are rubber, glass, wood, etc. So basically, based on this parameter, we can differentiate the three major materials, that is conductor, insulator, and semiconductor. Now, in basic electronics, we are going to work with semiconductor materials. So we are going to see that again, this semiconductor material can be differentiated or can be classified into two different types, that is intrinsic semiconductor and extrinsic semiconductor. Intrinsic semiconductor are, we can see that they are the pure form of semiconductor in which we haven't added any impurities, such as your silicon, germanium, where the number of electrons and the number of holes are same. Whereas extrinsic semiconductor are the type of semiconductor in which we are adding some impurities into our pure type of semiconductor. Based on what type of impurity we are adding, we can have two types of semiconductor, that is N-type semiconductor and P-type semiconductor. When we are adding a pentavalent impurities in our semiconductor, we can form a N-type semiconductor. And when we are adding trivalent impurities in our semiconductor, we can form our P-type semiconductor. We can also differentiate this intrinsic and extrinsic type of semiconductor based on this parameter. We can see that intrinsic, that they are the pure form of semiconductor, whereas extrinsic, they are impure semiconductor. The density of the electron is equal to your density of hole in your intrinsic semiconductor, whereas both the density of electron and holes are not equal in your extrinsic semiconductor. Electric conductivity is also low in your intrinsic type of semiconductor, whereas the conductivity is high in your extrinsic semiconductor. Intrinsic semiconductor depends on temperature, whereas extrinsic semiconductor depends on temperature as well as the amount of impurities we have added. In intrinsic, there are no impurities, whereas in extrinsic, based on the amount of impurities, we can say that we are having trivalent or pentavalent impurities.